This is how we install a ductless mini split for our field office. It's a 9000 BTU 120-volt Mitsubishi system.
All right, guys, here we have our indoor air handler. This is our ductless mini split, which is 115 volts. The American Standard labeled Mitsubishi. Guys, now that we've unboxed our air handler, we usually like to use these boxes to set the air handlers on. And check this out, guys. Both lids for this air handler box have a notch out on them so that you can place it right above the ladder and have a soft, cushiony spot to set your air handler on. So here we are, we've got the hanging bracket right here. Little nice features on this hanging bracket is if you see these indentations here, these actually mark where the refrigerant lines are going to be in case you're wanting to go to the left side of the unit. We've also got these nice little punch outs here for a level. So basically what we do is we present the bracket, make sure it's in the height that we want. Again, we want to be at least 6 to 8 inches from the ceiling to the top of the unit. So that puts us about right here. So we know that's going to be around the spot we'd like. I like to measure from the top of this is where the unit actually hangs on. And here we are again. About 8 inches there, perfect. Got my handy dandy level, and here's the punch outs they have here. This makes it real nice and easy, just sits there. Find our level spot. Boom, right there, perfectly level. Now we got it all leveled out and mounted. We'll go ahead and drill our penetration. Got a 2 9/16 hole saw. Again, I want to look at my line here that I made. I'm going to angle my drill so that I know exactly where the teeth are going to land. Now I'll angle it up. You want to remember to be very careful when you're making this penetration. You want to start slow with very minimal pressure. You don't want to put a bunch of pressure and then go through the drywall and then there be a water pipe or some sort of electrical back there, you'll destroy it. So what I like to do is just gently cut through this. All right, we got our penetration all the way through. And what I like to do is set a pilot hole all the way through from the inside. And then I take it and I drill my hole from the outside in to finish the penetration. One of the reasons is in case you're, if you're dealing with siding on the exterior or any type of veneer rock or anything like that, if you're drilling your hole straight through from the inside, on the other side, you're not gonna have a clean cut. It's basically just gonna blow the whole siding out or the stone veneer. Now that we've got our penetration all the way through to the exterior, we're gonna wait on our guys to send over the electrical control wire. We'll leave that hanging there, set up ready for us to wire this unit. So what I'll do is usually before I hang the unit, I like to remove the cover. That way we can set it in a nice safe spot and keep it from getting scratched. We'll remove the electrical panel in order to be able to feed our wire through. So it's just one screw. Now that's opened. We'll set our air handler on the ladder and we'll feed our cable through. It's a lot easier to do it before you hang the air handler. A couple of jugs there. Make sure we got at least 3 or 4 inches sticking out of the electrical panel. That way we have plenty of wire to work with. I like to set my ladder back up just a tad bit here. See how nice this little panel sits there? Just helps the installation process a lot easier and safer for the air handler. We'll turn this unit around, set it there again, start feeding the excess back. We'll step away a little bit, insert our refrigerant line, make sure our drain is again staying on the underside. And there she goes all the way through. Get up there, make sure we're snug on all the hanging brackets. We are. Now we're ready to snap it in place. Nice and snug. Again, they also add, Mitsubishi also has this side panel here that you can remove to access the drain and some of the electricals. And that you just press it in and poke it out. That way it allows you to have access to seal your penetration hole after you've already installed the air handler. As you like to just stick this on top while we continue. And there it is, nice and snug. Our hole is above the line, so again, you're not seeing the hole penetration after you hang your unit. That is very important because, as you can see, it doesn't show the hole. And there we are. We'll work on all electrical connections, put everything back together, and we'll be all done inside. We got a color coding sticker here on the terminal block, S1, S2, S3. This right here is going to be your line voltage. Again, this will act as a neutral, and this is going to act like your line because this is a 110 volt model. S3 will be the red wire color coded. This is going to be your signal wire, the communication between the outdoor unit and the indoor unit. While we're here, I'd like to show you your typical maintenance on these guys. You got 2 tabs on each side of this lid, 1 on each side. Pop it open on both sides. Lift the lid up. It holds itself up. Here's your filters. Pop open and slide out. Clean them from the clean side out. Shake them off and slide them right back in through these rails. You got 2 of them. These are lifetime filters. All you got to do is rinse them. You do not have to turn off the unit to clean the filters. It could be running. It could be cooling, actively cooling. So then after that, we've reinstalled our filters, and then again, these little tabs that hold it up, just pop down. Make sure you're in the side, center, other side. You're good to go. So now we've got our indoor unit all done. We're going to clean up this space, get rid of all the boxes and sawdust, and we'll move our operations to the outside where we'll spend the rest of the day hooking up refrigerant pipes, control wires, drain. Everything will be done through the outside. As you can see right here, we've got our line sets sticking out of the wall through our penetration, our liquid and suction line. We've got our drain placed nicely right underneath, and we've got our control wire. We're going to be hanging this this condenser here on a wall bracket up high as high as possible, really, just so that we were able to, bring in cars or something along the side of this building. In this application, we used stainless steel washer and bolts because, again, this is going to be on the exterior. We're going to have elements, and last thing we want is a rusted out bolt. I usually like to measure on the back side of the bracket because it's right on the money. So we're ready to hang this thing. So there we go. Line it up. So there you have it. Got plenty of room to service this condensing coil on the back of the unit. All right, so we got our bolts here to anchor the unit down. Again, we're using stainless steel M8 bolts. All right, guys, so we're gonna be ready to do some refrigerant pipe working. I like to tackle that first before any kind of electrical work or anything like that because the sooner I can finish up my refrigerant pipe work, the sooner I can put the vacuum on and I can wire the unit as I vacuum. So here's our refrigerant pipes coming through. We're gonna do a nice slight bend. We're gonna support it from this kink point back here. This hand right here will also bend, and this hand will assist in the bending. That way you get a feel of how this line set is bending on the kink point. You wanna avoid kinking these copper pipes. So there we go, just a nice little slow bend, ensuring support in the back so we don't kink. Point it down, and there we go. All right, guys, so we've got our 3/8 set, not torqued yet, but hand tight. You want to always start with your thicker pipe first, and then the thinner one is a lot easier to bend and manipulate to make it match exactly like the other one, like as you see here. You want to make sure that both have the same bend so that when we insulate over here, it's not, this guy over here and this over here, and then we can't wrap the insulation around. So you want to make sure it's nice and uniform all the way through. It looks like right here, we'll be able to land our flare. So I present it a little this way, just kind of hold it with my finger of where I think the flare will be, and then I'll add about 1/8 of an inch to that. I'll cut this back. We want to tighten this cutting tool slightly with slight increments so that we don't warp the actual pipe, because this is actually putting pressure against it with that roller blade. Slightly after each turn, just a slight little turn until we've made our full penetration. You want a nice round finished seam there, and there it is. So I can always come back and unbend this, point it down so that we can do our deburring, clean off any of the excess. And we're ready for our block. Again, guys, always remember to slide your flaring nut in. Flaring block to 1/4 inch. About a dime's thickness of excess above the flaring block. Slide in the press, make sure it lines up, nice and snug. Wait for the pop and the click. There it is, first one, second one. Now we back it out. And there we go. As you can see, another perfect little flare here with the no groove. Flaring nut slides right over and spins freely. Now we'll present the flare. Again, we're gonna butter it up a little with a little bit of this POE oil. Flare threads and the flare block and stuff. Flares and everything. Boom. Bring it over. Again, you want to present the flare, make sure it's nice and straight. Slide the flaring nut over and spins freely, you're good. Effortlessly. Got my Hillmore digital torque wrench here, ready to go. And turn this on. So typically for a 1/4 inch flaring nut, you want to have at least 13 foot-pounds of torque. And then for your 3/8, you want to do about 28 to 30 pounds foot torque. So I've already got my torque wrench set to 30 foot-pounds. So we'll slide this in, make sure it's nice and snug, and we'll start torquing. It'll show you the torque that we're currently in, and then an indicator light will light up once we get closer. It'll be green until it's red, red meaning you're there. So we're coming up. 27, 28, 29, 30, boom. As soon as you see the red light, you see you're there. Got 30.6 foot-pounds of torque on that flare nut. And naturally, you're going to want to wrap up these line sets and get it all done, but I usually like to wait until after we've done our pressure test to ensure that we don't have any leaks. So now what we're going to do is we're going to pressurize this system with nitrogen to 500 psi. We're going to leave it in for an hour and just to make sure that it holds its pressure. Ideally, you want to do 24 hours, so we'll do that, and then we'll come back to the vacuum process. We'll do wiring of the unit, a disconnect that will also allow us to plug a generator to the disconnect in case of a power outage. Here's the disconnect that I'm talking about. We've got an actual fusible pull right here, and then we also have a connection here for our generator. So the generator will run our mini split system. So now we've got our flares set and torqued. We're gonna get ready. We've already done our nitrogen pressure test. We're good, so we'll start the vacuuming process. When you're vacuuming, what you wanna do, what you're really doing is you wanna dehydrate the system. You're pulling this into a negative micron pressure, which will allow all moisture in these line sets and the evaporator coil to be vaporized. You want to eliminate all that within the line sets. I know so far this installs look pretty easy to do, but if you're a DIY person, I would highly encourage you hire this type of work out. And there are some DIY systems out there, they're all great, but 9 times out of 10 I'm called to go and fix those. So I highly encourage to hire a professional to do this, not only because of experience, and also when you're a professional, you'll have all the right tools, and one of those tools would be like a vacuum pump like we got here. And then of course you've got to have some digital gauges, and this one has a micron gauge as well. Another thing to keep in mind is when you hire this type of work out through an approved contractor, a Diamond dealer, for instance, like from Mitsubishi, you're going to get guaranteed craftsmanship, and you will also be able to take advantage of all the manufacturer warranties and such. Being a Diamond dealer contractor for Mitsubishi, we're actually able to offer 12 years parts and compressor for these units, which is excellent. If you buy this unit online and install it yourself, you're only going to be able to get what they call the box warranty, which is only 5 years, and that's 5 years from the date of the manufacture of this thing. So if this was made in 2020, It was installed in 2022. You're only going to be covered until 2025. So it's very important to hire a professional. That way you get to take advantage of all that warranties. These are great units, built very well. And if Mitsubishi is willing to put 12 years warranty on this, you know it's going to last way longer than that. Another thing about buying online is that in case you do need to use your warranty, if the online shop does offer warranties, you're going to have to go through them. You're going to have to go through their whole process of shipping and mailing, and that could be extended up to several weeks before you get your parts. So you want to make sure that you use a licensed contractor, preferably a Diamond dealer with Mitsubishi. That way, if anything does go wrong, he or she can just go straight to the supply house, grab the parts they need, and be back and service the unit same day in most cases. You want to make sure you hire a licensed Mitsubishi Diamond contractor. You can go online, look them up. Mitsubishi is really good at providing contacts for all their Diamond dealers. Here in Austin, Texas, we are a Diamond dealer elite for Mitsubishi. And you know, if you're in this area, we'd love to give you a quote, help you out with any projects or questions you may have. We do these for containers. We do them for garages. We've done them on Airstreams, she sheds, man caves, hot rooms in the house, any sort of comfort issue where ducted units are just not feasible. These guys save the day, and I'll tell you what, they're better than any ducted system. One of the feedbacks that I get from clients is that, say I install it in a garage for a man cave or any sort of room addition, folks never want to leave the room because it turns out being the most comfortable space in the whole house with these ductless mini splits. That's almost a guarantee there. So anyway, we're going to start off with the vacuuming process. We've got our vacuum pump set up here. We'll turn on the compound gauges. And these particular ones, they'll show your high and low side pressures. But once we get into a negative pressure or a micron level pressure, the display on these gauges will change and it'll display their micron readings. We've allowed this vacuum pump to run for about 45 minutes here. As you can see right here on our micron gauge, we're sitting right at 236 microns, which is excellent. We're going to just allow this to run a little bit more, run the decay test, meaning I'll valve off the pump and see how much it rises. And if we stay under 500 microns, we are good to release the refrigerant. And meanwhile, we've been working on all our electrical. As you can see here, we've got our conduit here. Here's our stub out for our service. I'm going to wire it into this wire here that goes to our disconnect. Here's our service disconnect. This is actually going to be acting as a service disconnect for this unit, and also we've got an attachment that goes into here and allows for us to switch over and plug in a generator. So on our decay test, we got up to about 300 microns and then it leveled out there. So that's an excellent number we want to be at. So we're good to go, guys. We're going to release the refrigerant next and finish up our electrical work. While the vacuum pump is running, we're gonna valve off the vacuum. And as soon as it's valved off, then we'll release the refrigerant. You always want to release it from the liquid side first. Just a quarter turn will be just fine. We'll go ahead and turn off our vacuum pump since we're done with it. And then we'll just slowly thread this out all the way until it's seated. Come down to our other valve and open up the suction. All right, now that we've released the refrigerant into the system, we're sure we don't have any leaks. Now it's safe to go ahead and insulate your pipes. So now we've got our line sets insulated. We've got our refrigerant released into the system. Again, we're gonna be working on the electrical now. I always wanna protect your communication wires. So we're ready with our comm wires. That gets threaded up to there. We'll make our connections exactly the same way we hooked up inside. We'll start with our grounding wire. Next, we'll land our communication and voltage wires. Exact same pattern or sequence as we did with the indoor units. Black wire to S1, which is our line voltage. And we'll use white as neutral for S2. And lastly, we have our communication wire, which is always labeled red for S3. Next, we'll land our main power wires to this terminal block, L1 and neutral. This is a 115 volt, 9,000 BTU, American Standard branded Mitsubishi heat pump. This heats and cools, and it runs off 110 volts. The compressor has very low starting amps or in-run shafts, so it'll make it ideal to supply this unit with power from a generator. All right, and next what we'll do is We've got our nice little penetration putty here to seal up our penetration. We don't want to have any hot air coming in and getting access to the back of the unit. The back of that unit may get cold and it'll condensate. So if we don't have a sealed hole or sealed penetration, we're going to have a moldy indoor air handler. So it's very important to always seal your penetrations both from the outside and the inside. That way you don't have the hot air mixing with cold surfaces from inside, and ensures you don't have any sort of condensation inside or mold growth. It's very common with these mini splits. You'll have the blower wheel full of mold and you'll have the blower full. You'll have very common to see a blower wheel full of mold and such, and a lot of the times it's just from not properly sealing your penetrations, allowing hot air to mix with the cold air from the air conditioner inside. Another thing too, properly sealing your penetrations, it makes it so that you ensure you don't have bugs or rodents, any kind of pests going inside of your dwelling. But it really was able to fill in all the gaps and such. And of course, usually we'll have a nice little cover here as well for a rain cover. We'll add that on later. And yeah, we're ready to start this thing up, guys. Power on. As you can see, we've clicked on. You can hear it. Now that our unit's been energized, we're going to check for proper voltage and communication between the indoor and outdoor unit. So we'll set our multimeter to meter out voltage and alternating current, AC. First, I like to check the power coming into the unit. So between L1 and neutral, we should be seeing at least 110 volts. We got 122 volts, so that's perfect right there between neutral and line voltage. Next, we're going to check line voltage going from the condenser to the indoor unit by way of S1 and S2. We should have 120 volts as well between those two. And yes, we do. 123 volts, so that means we're getting the correct power to the indoor unit. Next, we want to test for proper communication between the indoor and outdoor unit. What we're going to do is we want to check voltage between S2 and S3 using direct metering through direct voltage or direct current, DC. So we'll probe S2, we'll probe S3, and we should have a fluctuating voltage, a DC voltage signal, as you can see right there. If it's fluctuating like this, that means this unit is communicating with the outdoor unit. This is a digital signal, so different voltage patterns is a different signal to the indoor unit. As you can hear it, we've got our unit just kicked on, our compressor just kicked on, and our suction pressures are coming down. We were at a standing pressure of 200, now we're down to 106, 95. As this unit starts reading the different temperatures for the outdoors and indoors, and it'll level out itself to the proper suction pressure. So you can see we're down to 70, but it's crawling back up as this inverter compressor adjusts itself to the proper pressures. Again, guys, these are critically charged units, so if you put a set of gauges on this thing and you believe it's low on refrigerant, it's always going to display the proper suction pressure unless it's grossly undercharged. So you never want to charge using pressures on this. These are critically charged units, meaning it needs to have the proper amount of refrigerant. So if it's designed to have 2.5 pounds, that's exactly what it needs to have. This is a very quiet unit, so the load inside of the building is pretty high. It's warm, hasn't been conditioned all day, and so right now this unit is, according to its sensors, it's going to be running at its highest capacity. Fully, the hertz rating on the compressor is at its highest level, and so is the indoor fan. So as you can tell, this thing is running on its full load right now. I've got this impact drill here, and I just want to show you how quiet these units are. Here's the sound of our drill. And then on the background there's barely hear the unit running. Extra quiet operation. It's looking good. Got some nice warm air, meaning it's starting to pump out the heat from the inside. All right, guys, we're coming back into the office. This unit is running. It's blowing some nice cool air. Wow, that feels amazing. And look how quiet that thing is. You can barely hear it. We're going to check our temperatures for discharge temperatures. This is just going to read This is just going to measure surface temperature, but for this application it's close enough. We're just going to scan this blower wheel. Looks like the surface temperatures inside of this unit are already getting pretty low here. Look at that, 46 degrees, 47, 50. And then surface temperature coming in looks like around a 76. And our delta down to 48. So we have a really good delta on this unit. That's telling us that this unit is cooling the space. It won't take it very long because this is a small space. We did get a 9,000 BTU. That's the smallest size that you can get with this 115 volt 1-to-1 units. But either way, these units are fully modulating. So that means if it doesn't require 9,000 BTUs of heat load, then it's going to ramp down and it may be operating at 6,000 BTUs or 4,000 BTUs. That's what's great about inverters is they fluctuate their capacity. So if it's a 9,000 BTU unit, it's not going to be running at 9,000 BTUs always. It may run at 4,000 BTUs. It just depends on the load. All right, guys. So again, we're on a full load here, so we should be able to see what the maximum amp draw is going to be from this unit. And as you can see, on its high load, we're running barely 7 amps. So that's a really low amp draw for this unit. It's going to ensure that we can actually use a generator reliably. About 800 watts, yeah. So yeah, this is real low amperage. It's going to be real nice and easy on the utility bill, almost non-existent. Thanks for watching, guys. Till next time.